So yeah, let's just give it a shot. And let's talk about it. So explain the following. Oh yeah, also by the way, in case anybody somehow doesn't like, is not aware, I have notes for this course. It's www.tutor.ca/notes, and then you can go to that website and go to COE848, and then I have notes. It's all updated to the current, like to the midterm content. That's there. Yeah. Okay. So, anyways, this is first question. Following two terms: declarative language. We don't really have solutions for this, so it's it's good if it's discussions. If anybody at all wants to talk or just unmute. I'll also have the chat open, like the 848 chat open. So, but anyways, the declarative language is just like a type of coding language where you only specify what you want to happen and not the implementation. So you don't describe like it should be done with a for loop, and like you don't have any of that. You're just describing like that. If anybody has anything else to add, please go ahead. Otherwise, I'm just going to keep going. So union compatibility. This is the condition that between two relations that they have the same number of attributes, but they also each corresponding attribute has the same type. They don't have the same name necessarily, although we'd kind of like it to have the same name, but we don't really have, they don't have to have the same name, but it's like if the first column's names and the second column is dates, even if they have this, like if relation 1 has first column names and relation 2 has first column dates, that's not the same data type in the first column, so it doesn't matter if they have the same number of attributes. It has to be the same data type. So that is that. Right outer join. So right outer join. This is basically where you have like this is how I think about it. Like you take the Cartesian product and include only those rows which have matching attributes of the same name. So this is the same thing. This means that what I'm saying right here is the same thing as just a join. Same as just join. But you also include elements of the right relation that have no match in the other one. So a lot of words, but I'm just going to show you like the little thing that I did in, well, this is TikTok video ideas, so not TikTok video ideas, but this is, here's my notes. So I just made this little example here. So, because that's a lot of words that I did not understand when she was explaining that in class. So I just decided to make a little example here. So if you just do the regular, like, okay, so like here's your two tables, right? Here's the, where are they? Here. Here's the two tables. Movie, director. Same example like from class. And then you do like the Cartesian product, you get like this bad boy here. So let's specifically look at like the join, right? So if you make the join of the two, like specifically right here, I'm looking at the natural join. Then you're just interested in where like the movie director.id matches movie.id. So there's only one row where that happens. All the other rows those don't match. So the natural join would just be the highlighted section here. But the right outer join would include elements from the right relation that have no match. So you see ID2 Rosemary's Baby doesn't match with anything from the other set, but I still want to include it once in the table. And you just put null, null, null here. So that's kind of a little bit of a, not a mistake, but just kind of, I didn't quite indicate that, but you just put null, null, null. So the right outer join between these two tables would include the same thing as the join, right? It's always the same thing as you always have the join, whatever was in the join, but you're just adding on to the join. You're adding on for the right outer join. You're adding on like one instance of all the elements of the right set that have no match. So 2 doesn't match with anything. And then here for left outer join, right? Then 203 doesn't match with, like, ID 203 doesn't match with anything, so we include that once. And oh, sorry, I highlighted this wrong. Those should not be highlighted. My bad. Okay, I gotta fix that. These should not be highlighted. This should be null, 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 null. Sorry. Okay, so fix that. Anyways, but yeah, so because this is the left table, right? This is the director table, so it's these elements here. Hopefully that makes sense. If anybody has any questions, please feel free to unmute or whatever. Total participation. Okay, so when we were doing this in the class, I thought this was something and then I was wrong. And to be honest, I still don't quite remember total participation. I do not remember total participation. Total not found. Okay, so I don't have it here. Oh yeah, I was thinking of total specification. Partial specification. Does anybody remember what that is? Participation. Total specification. No, that's not
it. Wasn't like total participation like where one like element is like, I could be wrong, but like isn't it when it's like an element is encapsulated in another element, or
yeah, I see what you mean. Yeah, like I'm Googling it here, and it's saying total participation is where an entity must participate in a relationship to exist. So that's like a weak entity, I guess. That's another word for that. Total participation. Okay. If every participation entity in a relationship R is said to be total, if every entity in E participates in at least one relationship in R. Okay, so that means like so does that just mean that like you have like some entity E1 and then you have some relationship and then you have some E2 and then we say that E1 is in total participation if it's like 1 to many. This is what makes it a total participation, like that. That E is a total. I think that is it. I think I'm describing it right. So let me just see here if I can match it here. Where are we? This one. This is like week 3. Is this week 3? Yeah. Just search total bar. No, no total. Total. I don't want specification. I don't want specification. I think that is what it is. That the entity must be in a relationship with another. So it's 1 to many. At least 1, though. That's, I guess, what I have to say. But it's not necessarily like a weak entity, I guess. Okay, that's a little bit not sure, but I can maybe add to that later. Okay, so well, if everybody's good to move on, let's move on. So next,
Adam,
yeah.
Do you want to add that in the chat and like one of us can look that up while you move on to something else?
I mean, sure.
Like just
by
to
all
like
means.
double check and stuff.
By all means, like, go ahead. Yeah, take a look at what total. Okay, I'll just say total participation. I think it is what I'm saying here, where it's like that entity 1 is in total participation with entity 2 because it's required. But this more research can be done on this. We can circle back.
Sounds good.
So, question 2. Let us define a new relational algebra operation. Call it the antijoin, R triangle S, and define it formally as follows. The result of the antijoin is only those tuples in R for which there is no tuple in S that is equal on their common attributes. Express this using primary relational algebra operations. Explain your assumptions, if any. Use the following table to visualize how antijoin works, but do it in general. So we're only using, basically, we're looking for all the tuples in R. So first of all, the attributes of the antijoin will be the same as the attributes of R, of the original. And we're only looking at those which, when you join it with this, right, where there's no tuple in S that is equal on their common attributes. So let's look at the common attributes between this and this. The common attributes are department name and department name. So we look at this finance. Is there finance in here? No, there's no finance in here. So that's part of the antijoin. Sales? Is there sales in here? Yes. So this is not part of the antijoin. Finance, same thing. Production, same thing. So no. So that's how we get these things here. So let's think about this, right? I mean, we're going to do R minus something, right? Like we have to, because it's R, but you're just taking away some stuff. So R, or other way around, antijoin S is equivalent to, I mean, I think it has to be, I mean, I might be wrong, but I think it has to be R minus something. So then to figure out what we want to minus, well, we need to subtract the ones that do have a match, right? The ones that do match here. So then what we're going to do is we could join R and S, just regular join R and S. So then we'd get, just regular this. And then we'd only match, like we'd join these two together. And then we'd only get the ones where it matches. So what would we get? We'd get, so if we had employee join with department, then it's going to be name, whatever, employee ID, DEPT, name, DEPT, name again, and manager. Okay. And then I'm not going to write everything, but it's going to be just like Harry, Sally, George, Harriet. And then only the ones where I guess I'm natural joining, right? So where the department names match, right? So it wouldn't be Harry, Sally, it'd be, so this would match with nothing, right? Like this and this, nothing. This and this would match though, so I guess never mind. So we get like Sally 2241 sales Sally, and then this doesn't match with anything, and then this matches something, so we get Harriet 2202 production, and then Harriet. So this is what the join would look like. And so what we then want to do to this join is we just want to grab back the elements that are here, because these are exactly the ones, right, that we want to remove, right? Because here is just Harry and George. But we want, so that means Harry and George is what we want, but we want to remove Sally and Harriet. Well, perfect. That's what's happening here, right? We're removing, oh, are we? Sorry, hold on. Yeah, because this is I guess, sorry, I should, 2202 is Harriet. Yeah, Harriet. And this is going to be here, hair, because there's two H's, right? So, yeah, we're trying to remove Sally, and we're trying to remove Harriet. Well, here's Sally and Harriet. So we can take this, right, and remove it. But we can't quite just subtract it because it's not union compatible. So we need to just can we just say like that we're projecting the ones that are like employee.attributes. Can I just say employee.attributes? I don't know if I'm allowed to say that, but yeah. And that would be my answer, I guess. This one I think we can check. Yeah, same thing. Yeah, so just like, clarify what attributes. So employee.attribute here. Oh yeah, sorry, I can't say employee.attributes. Sorry, r.attributes, right? That's the only thing because we're doing in general here. But yeah, that is correct. So hopefully hearing that logic made sense of how we work that out. That's that question. There we go. Again, if anybody has any questions, please feel free to unmute or ask in the chat or whatever. I'm going to check that I'm recording my voice. I am. Good. It's good to know. So, question 3. Given the following table definitions. There we go. Those things. Provide appropriate relational algebra expressions for each of the following queries. Find the names of those parts that are green and cost more than $100. So this is easy because the parts already has the color and the cost. So we just take the parts and we select, right? We select, come on, there we go. We select 4, some theta, which theta is that the names of the part. Well, sorry, we want to find the names, but anyways, we want to select first of all the rows in which color equals green and cost more than 100. And then we want to project just the names of it, or p name, right? We just want to project the name of it after. We just want the names of those parts. So there's that. Then the next one here. Find the name of the parts that are sold cheaper than they cost to be built. So I think every question I'm just going to put this next to it. So cheaper than they cost to be built. So we need to be able to compare the cost to build and the price that they're sold for. And so since we need to be combining two tables, we need a join here, right? So no matter what, we need to do parts, natural join with catalog. Now, after joining these two, we're going to have a table that has PID, PName, color, cost, SID, PID, price. And so the PID and the PID will match for each row, right? Because we're doing a join. So the PID will match there. That'll connect them. So great. Now, from this, we need to select for the parts. I just put a theta because I don't want to write it like squished there. So I'm just going to say theta. And theta is, we just need to select for cost. So parts that are sold for cheaper than they cost to build. So cost is greater than price. Sold for cheaper than they cost to be built. Yeah. So we found that, and then we find the name. So we just need, again, project. And we just want the name of the parts, right? So p name. That is that. Compare here. catalog. Yeah, so I could have also, just comparing to the answer, I could have also done a theta join here. And it doesn't matter. This is totally the same thing. So we got an answer in the chat for total participation. Total participation is where an entity, participation can be total or partial. Total participation is where an entity must participate in a relationship to exist. For example, an employee must work for at least one department to exist as an employee. Partial participation is where the entity can exist without participation in a relationship with another entity. Yeah, I'll just paste that in here. Sure. Oh, that's annoying. I wish it wrapped text automatically. Do I just have to do this? Oh no, not that. Definitely not that. How do I fix this? Just put some spaces. That's how I fix this.
Yeah, sorry about that. My bad.
No. It's all good.
Yeah, it's just the weird characters got mixed in.
No, it's okay. There you go. So okay, there we go. That is our answer. So it's basically the same thing as like optional participation is like total participation is total participation is basically like a weak entity set then. Maybe let's Google this. What's the difference between weak entity sets and total participation? Yeah, so someone says, yeah, like on a forum here, it says a weak entity always has total participation with respect to its identifying relationship because it cannot be identified independently of its own identity. So there we go. It is pretty much the same thing. Okay. Let's keep moving here. So C. Find the names of all suppliers who sell at least one part for twice as much as it costs them to build it. Sounds good. Let's put this on the next page. I'll just copy this. So yeah, all these things where it's like there's one and there's two, or like the next one is like find the name of all suppliers who sell exactly one part. That's kind of the whole thing I want to practice because I don't really know how to do that, but you just figure it out. Anyways, find the names of all suppliers who sell at least one part for twice as much as it costs them. So basically, I think what we should do is we should take the suppliers and subtract all the ones who don't do that. Or does that matter? Hold on. No, I don't think that matters, actually. We're trying to connect suppliers with them selling a part for at least twice as much as it costs them. So we need to connect all of this, suppliers, parts, and catalog, because to find the cost, the price, and the suppliers, we need all of them. So let's just do it all. Catalog. And we're going to join all of them, right? Parts and suppliers.
Adam, when you're done writing, do you mind just quickly explaining why we're joining instead of multiplying
the Cartesian
them
product?
Yes, Cartesian product, yes.
Because this is the same thing as the Cartesian product, right? It's just that when you do the Cartesian product, there's a lot of rows that are just useless, where there's like SID from here doesn't match the SID from here. Like the row has like a mismatch between them. And we just automatically don't care about those rows. If I could do Cartesian product here, and then the first thing I would do is I would select for SID equals like a supplier.s, or I guess catalog dot PID equals parts.pid.
Oh, okay.
But instead of just doing that, I could just do this is the same thing, right? This is just a join, which is the same thing as that.
I see. Okay. Thank you.
No problem. No problem. Thank you for asking. So yeah, so there we go. So I've just joined all of them together. Now that we've joined all of them together here, and they all match and all that. So I have basically all the information together, and I think at this point I can just, well, what can I do? I can just select. What am I selecting for? Sells at least one part for twice as much as it costs them. So I'm just going to select for all the rows in which the price is greater than, well, this is for exactly twice as much. It's probably meant to be for, oh no, sorry. No, at least one part for exactly twice as much. So I guess we'll just equals 2 times. Price equals 2 times cost. So now we have all the rows in which the price is 2 times the cost. And this will exclude all of the people who don't do that, right? So everybody here, there might be certain suppliers here listed multiple times because they have multiple parts that fit this criteria, but that's fine. We're just going to select for supplier name now. And that should be it. Yeah, like it's written slightly differently, but I think it's the same thing.
Adam, I have another question for you.
Go for it.
So this is outside of this question, but have you found the textbook for this course useful at all, or not really?
I haven't even looked at it one time.
Oh, fair enough. Never mind then.
Well, sorry, that's a little bit of an exaggeration. I own the textbook. I just happen to own the textbook. So I have looked at it when I bought it at a thrift store one time. This is like a year and a half ago.
Oh, okay.
But other than that, I have not looked at it for the course.
Fair enough. Fair enough. Okay, thank you.
I think it's a pretty old textbook, so I think it's not quite exactly relevant. A lot of the things here, but anyways, yeah. So, okay, that's that. Part D. Now this is part D and E. These are the hard ones, right? Because it's like, I don't know, like find the name of all suppliers who sell exactly one part. So the idea is that you need to take all the suppliers who sell no parts and find all the suppliers that sell 2 parts. 2 or more parts, I guess. Well, 2 parts, right? Because if you sell 3 parts, then you also sell 2 parts, right? Like it's part of the thing. So find the name of all suppliers who sell 2 parts and subtract them off from the suppliers. So we should find all the suppliers who sell 2 parts, 2 different parts. And we got to be like, somewhat clever with how we do this. So I think the way we have to do this, suppliers who sell 2 parts, I think the way we have to do this is we have to match. We have to join, I think, parts with parts. Oh, come on. I think we have to join parts with parts. So now we have double table and PID. Oh, wait, hold on. No. Wait. Does this make sense? This will be all the rows in, like, this will just be the same thing twice, won't it? Yeah. This is fine, I think. Matching parts with parts? No, I don't know if it's parts with parts. Because we need to connect. Yeah, I think because the PID is also in the catalog and the SID is also in the catalog, it might actually be catalog with catalog. Catalog. I can't spell catalog today. Catalog. Catalog with catalog. And now we have rows where it's just the same thing on the left and same thing on the right. Like it's the exact same. It's like the table twice is what we're looking at here. And we need to select for rows. How do I put this? This is the thing I might look at the solution for this one to talk through this one, because this is the one that's confusing. Oh yeah, you got to rename it to identify which one's which. Yeah, that makes sense. So we got to rename them to identify. So let's rename this one as C1. So I'm looking at the solution now, but let me talk through it. I'm going to rename this one as C2. Right? So you have catalog 1 on the left, catalog 2 on the right. Now we need to join them, right? We need to join them on the condition. I guess I could just put theta here. Like I can just put join. Well, no. I want to natural join them. Oh no, I don't want a natural join them. Yeah, okay. This is the whole thing. This is the whole thing. Okay. So we're here. We have catalog with catalog. The point of having catalog with catalog is that we're going to be able to compare to figure out if there's multiple in the same catalog, multiple parts that come from the same supplier. And we're going to join them. It's a theta join. So we're going to have a condition here, theta. And I got to specify what theta is. Well, theta, we want to join catalog with catalog. We don't want to do natural join. Okay, so I a little bit misspoke before, because if we do natural join, you just have the same table twice. But that doesn't, you don't want the same table twice. That's not helpful. You specifically want to compare a table with itself, and you want to only take the rows where the suppliers are the same. So SID from the first one, C1 dot SID equals C2 dot SID. Right? So we have the same supplier and different parts. So C1 dot PID, right? Because C1 has a PID, does not equal C2 dot PID. Right? So now what do we have here? We have all the rows of catalog. Let me think for a second here. We have all of the rows in catalog. Catalog join catalog, right? This is what we have. Catalog join catalog. Let's just write it out. So this is going to be like, C1 is going to be SID, PID, price. And then we're going to have C2, which is again SID, PID, price. And we know that this matches this, right? So we're talking about the same supplier. We have the rows for the same supplier. But so when I just do the cross, right? When I just take the cross of the two, like the Cartesian product, then I have a bunch of mix of them. But we want the suppliers to match up. But we don't want the PIDs to match up, which implies that the same supplier is selling different parts, right? So this does not match with this, right? So don't just draw like this matches, and this we know doesn't match. So we know they sell at least two parts. This is the thing. We know they sell at least two parts. So now that we have the SIDs of all the people who sell at least two parts, we want to find the name of all those suppliers who sell exactly one part. So if a supplier doesn't sell a part, I'm assuming then they're not in the supplier. Yeah, then they're not going to be in the catalog list, right? So all the SIDs in the catalog list are the SIDs who sell at least one part, right? So if I take catalog, project just the SIDs, these are all the people. So yeah, let me see here. So let me write this down kind of in English. Table of tuples or suppliers that sell 2 or more parts. That's this, what I'm finding right here. And then table of, or table with SIDs that, let's say sell at least one part. Well, I mean, this is just catalog, right? Catalog, right? Catalog is a table that has SIDs, and all those SIDs, they sell at least one part because they're in the catalog, so they must sell at least one part. And these are the table of suppliers that sell 2 or more parts. Well, it's not just suppliers. My phrasing is a little off. Like, it's not just suppliers, but the SIDs are the IDs of suppliers that sell 2 or more parts. So then basically I can just, can't I just project? Yeah, I think I can just project so let's call this A1. Let's call this A2. So then I'm going to take A1. No, I'm going to take A2. I'm looking for the names. Find the names of all those suppliers who sell exactly one part. So I'm going to take A2, which is just all the catalogs who sell at least one part. And I'm going to project, I just want the names. Can't though, so I just want the SIDs. Okay. And then from this, I'm going to subtract all the people, so pi, from A1, just their SIDs. People who sell 2 or more. So now I have all the SIDs of people who sell exactly one. So now that I have the IDs, I need to convert that to names. So probably with this, I would do, let me just write down what we have here, right? This is a table of SIDs that sell exactly one part. Whatever, I'll call that A3. And then I want to take A3. What do I want to do with it? Well, I need to join it with suppliers, right? So now I have a table that has, we have a bunch of SIDs. Now I join it with suppliers, and I'm just going to project for their names, S name. Okay, I think that's the answer. That doesn't exactly match, because I think, yeah, that doesn't exactly match the solution, but I don't think there's only one solution, right? If anybody has any suggestions, I can go over it here, of course. But yeah, let's go over it here. So suppliers who sell exactly one part. My goal is to find the suppliers who sell 2 or more. So join catalog with catalog under the condition, call the left one C1, right catalog C2, under the condition that the IDs match and the PIDs don't match. So that means we have multiple, like we have one from this and one from this where the PIDs don't match. So there's 2 different products being sold by the same supplier. Call that A1. Then I want to get all the IDs of the people who have, at least one part being sold, and that's from the catalog. What might make more sense actually is to just project here. Project SID here. And then don't do it here. Okay. And then why don't I do that here too? Specifically, I'm going to project SID here. So now we literally have a table of suppliers that sell 2 or more parts. What's their IDs, right? And then table I can say of here now. Table of SIDs that sell at least one part. 2 or more, at least one. The difference, don't need this anymore. The difference between them is going to be the ones that sell exactly one, right? 2 or more minus the ones that sell at least one. The ones that sell exactly one. And then I need to find their name, so I'm just going to join it back with suppliers to match the SID to a name, and then A3. This makes sense to me. Again, not exactly the same as the solution, but I think this is correct. So, I could maybe send this in to her and ask if it's correct. But there we go. Okay. Any questions about this? Feel free to let me know. Okay. I will try the next one. So the next one here, it says find the name of those parts that have the highest cost for being manufactured. Highest cost. So again, we need to compare parts with themselves. So I'm fairly certain right away we need to compare cost. Like we need to join cost, highest cost, right? Parts with the highest cost. So parts with parts. But again, you need to differentiate them. So we're going to rename parts to C1, and we're going to rename the other parts to C2. So now you have a big table, parts and parts. I can write it out here. Right? So this is going to be like PID, PName, color, cost, and then again, PID, PName, color, cost. And then we're specifically joining with a condition here, some theta, right? And that theta is going to be what? Well, let's see. Okay, so we're comparing parts to parts. We want to find the part with the highest cost. When I join these, we want, first of all, we want PID C1.PID to not match with C2.PID because we don't want to be comparing a product with itself. Okay, part with itself. And we want, there's 2 ways to figure this out. I mean, I'm kind of just remembering from lecture. I think what she did was we found all the parts that were cheaper than other parts. So that means that we find ones in which C1.cost is less than C2.cost. So you find parts that are cheaper than other parts. Yeah, I think that's right. So then we need to, from this, now we have a big table in which we know that, let me, do my little drawing again here, right? These don't match. Don't match. But we know that this and this, let's just go like, let's go like this, that the cost here is greater. So in other words, all of these PIDs are ones which are cheaper than other parts. So if I project here, and I just take C1.PID, then what I found is I found the PIDs of all parts which are cheaper than other parts. Let's call that A1. And then I think all I want to do is I want to go to all the parts and, subtract off project it, right? Project just the PIDs. Well, I guess what should I do? Yeah, I guess I'll just say project it. I'm just going to take the PIDs, so that's a nice PID. And then I want to subtract off A1. Call this different color. Call this A2. So now we have all the IDs of that highest part. IDs of the parts that are not cheaper than any other part. So we just need to convert to names now. So I think this is what division's for. I'm not using division, but I think maybe I should be using division here. Anyways, I think I'm just going to A2. I'm going to join it with parts. And then I'm just going to project, P name. And I think that's it. So let's compare it to the solution. Again, we check that C1.PID is not equal to C2.PID. Oh, I guess I don't know why I called it C again, but yeah, I guess I shouldn't call it C. Like that's for catalog, so I'll call it P. P. Doesn't really matter, but just P. So yeah, PID, and then the P1 cost is less than that one, and then the result. So the result is less work than what I said. Let's see what the difference is. So we just subtract off. Oh, I guess we can just get the names. Yeah, that's true. We can just get the names directly here. I don't need to do all this. Instead, from here, I can just select the names. P name. Right? So I can just find the names. P names, right? P names of all parts which are cheaper. So now that I have that, I don't need to do this specifically. I can just kind of compare parts and select for or project for the P names here. So these are just all the names, and I can just take away A1. And that's it. So all the other lines I had there were just was just to get the names from the PID, but we don't need to do that here. Here we needed to do that because we were doing catalog, and catalog does not have S name, so I needed to do some funny business here at the end. But this one we don't need to do that. Okay. Otherwise, this does match, yeah. So that's that. Okay. Again, I'm just going to keep going, but if anybody has anything you want to ask, please feel free, or please let me know. I'll just pause here for a second, see if anyone has any questions. Okay, so 2 more questions. Next question is finding the convert the ER diagram into a database schema. Now, I wish I copied the solution for this one. I didn't. But if anybody has a solution, that would be helpful to see, like what she wrote. I did not copy it, and she erased it really fast. So I'm assuming nobody has it. But if anybody does, please let me know. So this question here, we want to convert the ER diagram database schema, indicate the keys for each table in your answer. For table T with attributes PK, K is the primary key, you can use the following notation in your answer. So we'll do that. So let's think about how many like relation tables we're going to need. So we're going to need definitely employee. Right? Employee. We're definitely going to need, well, let's just do one at a time. So employee. Employee is, first of all, it has a bunch of, well, let's look at what the primary key is going to be. First of all, SSN is primary key. Also, we have 1-to-1. So if we have 1-to-1, then do we need to make a table for it? I forget if we need to make a table for it. I know we need a table for many-to-many. I forget what I think we need a table for 1-to-1, but we don't need a table for 1-to-n. I think that's the key thing here. You know, please correct me if I'm wrong, but I think that's what it is. Let's see. See my notes here. So if I'm looking at the relations, where am I? I have a table, entities to relations. Yeah, this is just like that stuff. Then, no, this is like is a relational algebra, not that. So 1-to-1, yeah, 1-to-1. Wait. Oh, no, here. This is what I want. Right? Relationships to relations. 1-to-many. 1-to-many, you just put the foreign key of the other. So that we'll talk about that. Many-to-many, you make a new relation, exactly, where it's the two foreign keys of each other just combined. And then 1-to-1, you do this, but yeah, it looks like you make another one, right? Oh no, sorry, that's for that one. 1-to-1. For E1, create a relation R1 with the same attributes and keys as an E1. Do only one of the followings. Create a new relation R3. Add the key set of E1 to R3 and make them primary key of R3. Add the key set of E2 to R3 and make them candidate key of R3 and mandatory. This is the thing that always confused me. Candidate key and mandatory is not a candidate key anymore. It's just a secondary key. It's like still part of the primary key, I guess. It's an alternate version. But okay. Right? I guess that's what it is. So I will do that. For 1-to-1, I'll make a separate one. So anyway, for employee, right, we have our primary key of employee. Our primary key of employee is SSN, right? So SSN. And then we have all the other stuff, right? We have, F name. We have whatever, all this, right? Last name, sex, address, salary. Well, then also an employee is in a relationship 1-to-many, right? 1-to-many relationship with another employee in terms of the supervision. So because of this, and also we have dependents of, didn't even see that, which is also a 1-to-many, right? So, but here, it's the many that's going to be getting the foreign key of the employee that is they're dependent of, right? The dependent is going to deal with this relationship. Here, the employee does need to deal with the foreign key, right? So I think what I have to say after this, I forget how the notation, right? But like the foreign key is like, the SSN. I don't really know what the notation for this. Like just say foreign key SSN, I guess. Like the SSN of the other employee that they are supervising. So you have like 1-to-many. So it's kind of this direction, right? Which one employee is supervising this employee. So I'm just going to say like of supervisor. So there's that. I don't know. Anyways, that's employee. Oh, I didn't see birth date. B date. Anyways, then we have like, why don't we do dependent next? Just because like I want to go left to right. So why don't we do dependent? Right. So dependent, first of all, has a name, right? But it also has the SSN. Why don't I say like employee dot SSN, right? Like the SSN of the employee that it belongs to. And then, sex, birth date, relationship. So that's our dependent. Then the foreign key. Do I have to say the foreign key? I don't know if I have to say. This is the thing I don't know, right? This is like, I don't know if I have to say foreign key. I guess I do. So like the foreign key is employee.ssn. A little uncertain about how to actually write this, right? But yeah. Sorry, give me just 10 seconds. 1 second. Okay. So now that we have this, we have employee, dependent, foreign key. I think they're done. And their relations. So, well, not necessarily their relation, I guess, to other things. Oh, okay. I guess so sorry. Employee also, right, works for a department and also this. Okay, but so that we'll deal with later. But this one, n to 1, right? Many to 1 or 1 to many. We also need to add something here, right? Which is the department that they work for. So we also need department name and number. So I'll kind of hide that, right? And then we also need, so I guess I won't put this here. But then we also have FK, I'll say department dot name, department dot number. So yeah, that's that. So that's employee and dependent done. Then we still have to do department, project, and then a couple of these relations. These couple of relations here. So let me just kind of like number it. 1, 2. So then 3. May as well do department. Right, so the department has a name, has a number. Right? It's also related to multiple locations, right? Locations can be their own entire entity. And so this is a 1 to many relation, right? Like one department can have many locations. So that's fine. I mean, whatever. So we'll deal with that, right? And but that's not part of the department specifically. So that's the department has a name. The department has a number. Now the department is related to many projects. Don't have to deal with that. Many locations. Don't really have to deal with that. It just has number of employees, but number of employees I think doesn't even get its own place in the like schema because it's a derived one. That's what the dots mean, right? So I think that's it for that. There's no foreign key. Yeah, I think that's it for that one. And then for 4, why don't we finish up there and we say we'll deal with the locations, right? Locations. So locations probably has like a location, right? Like has a specific location. Or maybe an address, right? We'll just assume this here, address. So since it has an address, right, we can make that a primary key, but also we need the primary key of the department, right? So that's going to be a foreign key. So I might just add that underneath here as foreign key, which is department dot name, department dot number. There we go. And so that's that, department name, department number, and that's really it, because that's all that location is related to. So not too much more. Let's do project next. So I'll do it over here. So project. So project has notably name. It has number. It also has a location. Okay, now we gotta start figuring other things out, right? So it also has a department, but that's a foreign key, right? That's a foreign key, the department that it's in. So department dot name, department dot number, department dot name, department dot number, because it's a many to one, right? So we got to figure out just which one we're connected to. Now, that might be it, actually. That might actually be it. So then we just have these relations to deal with, right? These one-to-one and many-to-one. Many-to-many, I mean. The many-to-ones, which is whatever all the other relations have been so far, are you just deal with them as foreign keys. But then we need a separate relation for, employee works on project, right? So let's say works on. So first of all, what we need is the foreign key of both of the things that we're dealing with here, right? So the foreign key of the primary key, of each of the things on either end of the relation is what I'm trying to say. The primary key of this and the primary key of this. So the primary key of the employee is just SSN, right? So I'll say employee.ssn. SSN. And then we also need to say, and this is like a primary key of the relation, and then we also need to say, project. I might not write it like this. I might instead just write it as works on just has hours. And then the foreign keys are employee dot SSN and then project dot name project dot hours. But I need to somehow indicate that these are mandatory, so I'm still going to say like that. like indicating that they are mandatory. Well, that they are like, yeah, they're mandatory. They're primary keys. The underlines, I'll just like literally write that here, like underlined to indicate they are primary keys. And that would be the works on relation, because we need the foreign key from like primary key of this, which is what we have. And then it also just has hours. And then finally, we just have this manages, right? So for number 7, we have manages. So for manages, it's 1-to-1. So for 1-to-1, it's the same thing, right? We have the, what did I say in my notes here? Add the key set of E1 and make them primary key set of R3. Yeah. Add the key set and make it candidatory and mandatory. Yeah. I didn't do anything with candidate keys here, you know? So maybe I'm missing some candidate keys. I'm not sure. It'd be nice if someone had the solution from the prof, but I think she deleted it too fast. Anyway, so manages is going to be 1-to-1. So I just need the, there's start date, right? Start date is just a normal attribute. And then there's a foreign key of the R1, right, which is just employee.ssn. SSN. And then make it the primary key, so I'm going to underline it. And then I also need the I'm going to do this and treat it as like a candidate key. Candidate key. But make it mandatory. That doesn't really make sense to me, to be honest with you. But anyways, this is going to be department dot name department dot number. Department dot name, department dot number, and then again, I'm just gonna make these like mandatory, so now they're primary keys as well. I don't know. Okay, I guess I'm done. So yeah, that is that. This, I definitely am not super confident in my answer with this one. It's possible because I didn't write many candidate keys, and I feel like there were more candidate keys before. So I may email the prof and see if she responds. I don't know. Hopefully she's responsive. I don't know. Yeah. If anybody has any suggestions, please feel free to let me know. Hello.
Yeah, no, I was gonna say, yeah, thank you for covering all that. It's been really helpful listening and getting your insight on everything.
Glad to hear. I appreciate that. I'm happy to. We still have one more question, in case you think I'm going. We still have one more question.
So. Oh, okay. So my bad, but yeah.
No, but I still appreciate. I still appreciate it. Yeah, that's great. That's great. So yeah, let's do the last question here, and then we'll be done. Hopefully, we'll be done in 10 minutes, because soon it's time to go to sleep because I'm up very early tomorrow. But anyways, so suppose you are given the following requirements for a simple database for National Hockey League. NHL has many teams. Each team has a name, a city, a coach, captain, set of players. Each player belongs to only one team. Each player has a name, position, such as left wing or goalie. a skill level, and a set of injury records. I hate when lists are improperly bulleted, but I'll just have to live with that. Where am I? Where am I? I'm trying to erase it. There we go. Oh, that's a good strategy. There we go. A team captain is also a player. A game is played. Sorry. A game is played between two teams, referred to as host team and guest team, and has a date, a score, such as 4-2. Construct a clean and concise ER diagram for the NHL database schema, list your assumptions, and clearly indicate the cardinality mappings in your ER diagram. Okay. So, clearly we need teams. Team is an entity that we need in our ER diagram. We also need, so each team has a name. Each player, we have player. Each player belongs to only one team. Each player has a name. A team captain is also a player. A game is played between two teams. Okay, so has a date scored. This might be all we need, except that also player. You know, we could also put, if I just first of all put this in a little box, and then we have also, you know, captain.
Hey, there's one thing I want to ask. Isn't
Yeah.
player also an entity of team or
Well, is a player like when it's an entity of the entity set, then that means like it's an example of it, right? So like, but a player is
oh,
not an
okay.
example of a team, right?
Okay,
They're
fair
their
enough.
own.
That makes sense
They
when you
have
say
their
it like
like
that.
different attributes. Yeah,
Got it. Okay, thank you.
no problem. So yeah, so there's a relation between a team and a team where it's, you know, plays. Let's say plays here, plays, and this is a, you know, one of these guys. So one team can play multiple teams. So this is like, well, we like teams that have played at least one game, right? So it's like, is it one to many for both of them? No, hold on. That doesn't make,
Sorry,
wait,
say that
that might not
again.
make sense. That
Like,
might not make sense. Well, because we know that a game is played between two teams, right? So I guess I could make game its own entity.
and then make it like one game to many teams.
Yeah, I'm not quite sure about the is it, but when it that might actually be no, that doesn't make sense. I think it is one to many because so I could make it its own entity, but I don't have to make it its own entity. I can just say that there's a relation between two teams if they play each other, right? So like team A plays team B. And
Yeah,
any
but then you could also
yeah.
argue that multiple like more than two teams play games, but then I mean that just diving into a different thing altogether.
But I think that's fine allowed because I say many here, right? So let's say like, you know, let's say this is like plays and is played by, or what's the better way to say this?
Why not just make it many to many at that point?
Yeah, I have many to many. Exactly. I have many to many, right? I have like many teams can play many other teams.
Oh,
That's
true. Okay.
with the
Okay, but then you
little
can also
tents.
say many teams play many games, right? Because
Yeah.
uh as well. So I mean it could be so like on the other side of that diamond you could put games there as well.
Mm-hmm. I could.
And and then you could connect games. Games are played by like one game is played by or many to many, so many games are played by many teams as well if you really wanted to like hook up
Yeah.
everything.
Yeah. No, I get it for sure. Yeah. Let's see. So the primary comparing to this here.
Mm-hmm.
If I had employee. Okay, let's make it its own entity then. That might be easier. Because right now it was a relationship, right? It wasn't its own entity. So we have a game entity. Oops. No, not later. We have a game entity. So a game a game is related to how do I indicate this? This is kind of harder than I thought.
What are you trying to associate it to again?
Like just like
To
I'm to teams.
game. Let's say many games are played by many teams, and mm,
Well, but like only exactly two, right? Like exactly two teams, but
oh, okay,
I guess that's fine. So one game is associated with definitely at least one to two to men, but it's two. It's exactly two. You know what I mean?
right.
Like game is played
I
between
mean,
two
it's still
teams.
classified. It still falls under the umbrella of one to many. So I mean,
I guess so. Yeah. And then a game. Sorry. And then a team plays one to many games. Right. And a game has a host team. Right. And this is a let's say probably a primary key, and then guest team probably also primary key, and then we also have here this is we also have date, which is probably also primary key, and then we have
would
score.
you say league as well?
They don't really talk about league in the question. They just say NHL. So
Oh, okay,
I'm
fair enough.
assuming this whole thing is just the one league. Like this whole thing is a league,
Okay,
right?
got it.
Team has a name.
Oh, you could also say like players in a game, or like players as an attribute of game.
I think instead I would say player is related to team, which is related to game, right?
Okay, I get, yeah,
You know what I
that
mean?
that does
Like
sound better. Yeah.
because I think that's more what they want here. Right?
Okay, fair enough.
You could. This probably is a way to relate, but I think this might work better. Anyway, so
It's more straightforward the way that
yeah,
you're saying it. Yeah.
yeah. So a team has a name, a city, but probably name is all that's needed for the primary key. It's probably only one name per team.
Yeah.
It has a coach. So this is. Do I actually need these? I think I do. I don't know. Okay, I think I do. So, anyways, coach.
A captain, or
Yeah,
that's its own.
captain. Yeah, it's in the list here. Right?
Yeah.
Captain,
Okay.
captain, or captain. Sorry, captain. And then I also need a set of players. But do I actually need to list that as a? I don't know.
No, I
Okay,
think you could line it
maybe
up like you did
just
before as
relate this here.
a entity. Yeah.
So then, a team, a player is related to. A player has a
Many to
name, a
one.
position, a skill level, and a set of entries. Well, one player, let's say, is on one and only one. Yeah, a player is on one and only one team.
Yeah, so a many to one, yeah, many to one relationship. Right,
Yeah,
like
and
many
a
players to one
team
team,
has
yeah.
one to many players, like that.
Right.
Okay, and then a player. Uh, okay, so then player here, and then team. A player has a name, which is probably the primary key. And then a
Yep.
position. And then also skill level.
I was gonna say goals as well, maybe, or
Yeah,
position, but you
I'm
already have
just
that.
like I'm just like following what they have here, right? So we don't really need to come up with anything kind of. It's just like I'm just gonna
Oh,
follow
true, true,
what they
true.
give here, right?
Got it, got it. Sorry.
Yeah, no, but it's a good idea, right? Yeah. And then a set of injury records. So I don't know, I'll just say injuries and then make that like a multi-valued attribute. So it's a double circle. It's a multi-valued attribute. So it's like multiple injuries.
Okay.
And then a game is played between two teams. And so yeah, and then it has a score. And then we just need to relate captain here. Well, captain is a player. So I need to just somehow show Iza. And to show Iza.
Yeah, you can put it in the just the diamond. Oh wait, no.
Oh yeah, the double
Triangle
line
there.
diamond. Yeah, that's right. So the double line, I
Yeah.
guess, triangle. So then I guess I just say Iza. Um, and then how do I indicate? Oh yeah, partial total in which an entity from the parent set must be a member of at least one child entity set. Yeah, so no, so we want total.
Yeah, yeah.
And then what's the difference between nothing? Yeah. So that's what we want. Yeah. We want this here like that.
Mm-hmm.
Okay, so NHL has many teams. That's fine. There's many teams. Each team has a name, city, a coach, a captain, a set of players. City, coach, captain. Um, then, well, okay, but yeah, so maybe instead of saying captain here, I just make a relationship like this, right?
But then what relationship would that be? Like it has a.
Oh yeah, I have to. Hold
So
on.
it'd be a diamond again in this case.
Yeah, I just realized I have to be putting. Diamonds in between here. Don't I? Wait, do I have to be putting diamonds in
Yeah,
between?
I mean that. I think you do. Yeah.
Yeah.
Works on
To
controls. Yeah.
to explain the relationship, right? So I don't know, plays on, right? It's like a player plays on a team,
Mm-hmm.
and then here I also have to put one, so I'll put a diamond. Like I'll write it first, but I'll just plays, I guess. And there we go. And then has between a team and a captain. So a captain has one and only one team, and a team has one and only one captain.
Mm-hmm.
Okay. And I think that might be it. Team
Yep.
has a
Yeah.
name,
No, you got
city.
everything.
Okay. Then I think that might be it. There we go.
Thank you so much.
Yeah, no problem. I guess that's the whole sample. How do you
Yep.
feel for everything?